Hello everyone, welcome again. In previous 8 videos, we have discussed a lot about Z transform. Now in this video, I am going to discuss some university questions on Z transform. So our first question is, find the Z transform of unit impulse function. And as we know, the unit impulse function delta n is defined as 1 when n equal to 0 and 0 when n is not equal to 0. And we find its Z transform. So given function is delta n, whose value is 1 for n equal to 0 and 0 for n not equal to 0. Now we know that by definition of Z transform of a sequence un is given by Z transform of un is summation n goes from minus infinite to plus infinite un into z power minus n, bilateral Z transform. Therefore, the Z transform of given sequence delta n is what? Z transform of delta n become summation n goes from minus infinite to plus infinite delta n into z power minus n. Now we split this integral, this summation in 3 parts for the negative range of n, that is from n equal to minus infinite to minus 1, then for n equal to 0 and n equal to 1 to infinite for positive range of n. So by splitting this summation we get Z transform of delta n is equal to n goes from minus infinite to minus 1 delta n z power minus n plus summation n equal to 0 delta n z power minus n plus summation n goes from 1 to infinite delta n z power minus n. So the negative range of n for n equal to 0 and for n equal to 1 to infinite, that is the positive range of n. Now for in negative range n is not equal to 0, and when n is not equal to 0 the value of delta n is 0. In the positive range for n equal to 1 to infinite n is not equal to 0, again for n not equal to 0 the value of delta n is 0, and here we have delta 0 z power 0 for n equal to 0. So we write n goes from minus infinite to minus 1, value of delta n is 0 into z power minus n, plus for n equal to 0 we have delta 0 into z power 0, plus summation n goes from 1 to infinite, the value of delta n is 0 because n is not equal to 0 in this range, z power minus n. So we get here the summation gives 0, here the summation gives 0 and z power 0 is 1 and delta 0, here n equal to 0, so value of delta n is 1, so we have 1, and finally we get the Z transform of unit impulse function delta n is 1. So this is how we can find the Z transform. Next example is, find the Z transform of discrete unit step function which is defined as un equal to 1 for n greater than equal to 0 and 0 for n less than equal to 0. This function is called unit step function. For n greater than equal to 0 the value of unit step function is 1, and for n less than equal to 0 the value of unit step function is 0. Now we find its Z transform. So the given function is un equal to 1 for n greater than equal to 0 and 0 for n less than equal to 0. Now by definition of Z transform we know that Z transform of the sequence un is defined as Z transform of un equal to summation n goes from minus infinite to plus infinite un into z power minus n, bilateral Z transform. Therefore the Z transform of given function un is equal to, here we split this summation in two parts for negative range of n, that is minus infinite to minus 1, and for the positive range of n, that is from 0 to infinite. So we have z transform of un is equal to summation n goes from minus infinite to minus 1 un z power minus n plus summation n goes from 0 to infinite un into z power minus n. Now for negative range of n, the value of un is 0, and for the positive range of n, the value of un is 1. So we get summation n goes from minus infinite to minus 1, the value of un is 0 into z power minus n, plus summation n goes from 0 to infinite, and in positive range of n, value of un is 1 into z power minus n. This summation gives 0, and from here we get summation n goes from 0 to infinite z power minus n, which become, putting the value of n equal to 0, 1, 2, 3 and so on, we get, for n equal to 0 we get z power 0, which is 1, plus for n equal to 1 we get z power minus 1, which become 1 upon z, plus for n equal to 2 we get z power minus 2, which become 1 upon z square, plus so on. Now this series is clearly a geometric series with first term a is 1 and the common ratio is 1 by z. And as we know, the sum of GP with first term a and common ratio r is a upon 1 minus r. So here a, first term is 1 and the common ratio r is 1 by z. So sum of this geometric series is 1 upon 1 minus 1 upon 1 minus 1 upon z. Now simplify this, we take z LCM, then we get z minus 1 upon z, and then this denominator z goes in the numerator. Then finally we get the z transform of unit step function un is z upon z minus 1. Now the region of convergence. Region of convergence is what? Mod r is less than 1. The region of convergence is what? Mod r is less than 1. That is, common ratio is 1 upon z. So 1 upon mod 1 upon z is less than 1, which gives mod z is greater than 1. So this is the region of convergence. For the region of convergence, mod r should be less than 1. Next example is, find the z transform of the sequence un where un is defined as 4 power n for n less than 0 and 3 power n for n greater than equal to 0. Now we find the z transform of given sequence. So by definition of z transform of the sequence un is given by z transform of un equal to summation n goes from minus infinite to plus infinite un into z power minus n. Now we split this summation in two parts for the negative range of n minus infinite to minus 1 and for positive range of n 0 to infinite. So after splitting this summation we get z transform of the sequence un is summation n goes from minus infinite to minus 1 un z power minus n plus summation n goes from 0 to infinite un into z power minus n. Now for negative range of n, the value of sequence un is 4 power n, and for positive range of n, value of sequence un is 3 power n. So putting the value of un, we get summation n goes from minus infinite to minus 1, and for negative range value of un is 4 power n. So 4 power n into z power minus n plus summation n goes from 0 to infinite, and for the positive range of n value of un is 3 power n. So we have 3 power n into z power minus n. Now we write this is z power minus n upon 4 power minus n. So z by 4 whole power minus n. Summation n goes from minus infinite to minus 1 plus summation n goes from 0 to infinite. Here we write 3 power n upon z power n. So we get 3 by z whole power n. Now we expand these summation by putting the values of n. For the first summation, we start from minus infinite and then we come to minus 3, minus 2, minus 1. Then we have from infinite to, for n equal to minus 3, we have plus 3. So z by 4 whole power 3 plus for n equal to minus 2, we have plus 2 here. So z by 4 whole square plus for n equal to minus 1, we have plus 1 here. So z by 4 plus this summation we expand by putting n equal to 0, 1, 2, 3 and so on. Then we get for n equal to 0, we get 3 by z power 0 which is 1 plus for n equal to 1 we get 3 by z power 1 plus for n equal to 2 we get 3 by z whole square plus so on. So these two series are geometric series. This series is geometric series with first term z by 4 and the common ratio is z by 4, and this series is a geometric series with first term 1 and the common ratio is 3 by z. So the sum of GP is a upon 1 minus r. So for this series first term is z by 4 upon 1 minus r is common ratio and which is z by 4. So we have sum of this series is z by 4 upon 1 minus z by 4 plus for this series the first term a is 1, so we have 1 upon 1 minus r is common ratio, and for this series common ratio is 3 by z. Now simplifying these two, we get, taking 4 LCM and then 4 goes in the numerator, then 4 to 4 cancel, we have z upon 4 minus z plus here z is LCM, so we get z minus 3 by z. So this LCM z goes in the numerator, then we have z upon z minus 3. Now simplifying by taking LCM, we get minus z upon 4 minus z into z minus 3. So this is the z transform of the given sequence. Now for region of convergence, as we know, for the region of convergence, mod of common ratio r should be less than 1. So for this series the common ratio is z by 4. Therefore for convergence of this series we have common ratio mod z by 4 should be less than 1, and which implies mod z is less than 4. And for a second series common ratio is 3 by z. So for convergence of this series we have common ratio mod 3 by z should be less than 1, and which implies mod z is greater than 3. So the region of convergence is 3 is less than mod z, which is less than 4. So the series is convergent between 3 and 4. So mod z equal to 3 is the circle of radius 3 with center at 0, and mod z equal to 4 is the circle of radius 4 with center at 0. So the area between these two circles, this annulus, is the region of convergence for the given sequence. Next example is, find the z transform of the sequence un where un is defined as c power mod n. C is the constant. Now we find its z transform. So given sequence is un equal to c power mod n, and also we know that mod x is negative x for x less than equal to less than 0, and mod x equal to x for x greater than or equal to 0. Now by definition of z transform, we know that z transform of the sequence un is defined as summation n goes from minus infinite to plus infinite un into z power minus n. Now we split this summation in two parts for negative range of n, that is from n minus infinite to minus 1, plus for positive range of n, that is summation n from 1 to infinite, 0 to infinite. So after splitting this summation, we get the Z transform of the given sequence un is summation n goes from minus infinite to minus 1, and the value of un is c power mod n into z power minus n, plus summation n goes from 0 to infinite, the value of un is c power mod n into z power minus n. Now for negative range of n, the value of mod n is minus n, so here we have c power minus n, and for the positive range of n, the value of n mod n is n, so here we have c power n into z power minus n. So we have summation n goes from minus infinite to minus 1, c power negative n for negative range of n into z power minus n, plus summation n goes from 0 to infinite for the positive value of n, mod n is n, so c power n into z power minus n. Now we write c power minus n into z power minus n is cz whole power minus n, and here we write c power n upon z power n, which becomes c by z whole power n. So we get summation n goes from minus infinite to minus 1, cz whole power minus n, plus summation n goes from 0 to infinite, c by z whole power n. Now we expand this summation by putting the values of n. So in first summation we start from n equal to minus infinite, and then we come to n equal to minus 3, n equal to minus 2, and n equal to minus 1. So we get from minus infinite to, for n equal to minus 3 we have plus 3 here, so we have cz whole cube, plus for n equal to minus 2 we have plus 2 here, and then we get cz whole square, plus for n equal to minus 1 we have plus 1 here, then we get cz, plus here we put n equal to 0, 1, 2, 3 and so on. So for n equal to 0, c by z power 0 is 1, plus for n equal to 1 we get c by z, plus for n equal to 2 we get c by z whole square, plus so on. These two series are geometric series. First series is geometric series with first term c by z, first term cz, and the common ratio is also cz. And for the second series, first term is 1 and the common ratio is c by z. So sum of in geometric series is a upon 1 minus r. So we get here first term is cz, so we write cz upon 1 minus r is common ratio, which is cz, plus here the first term is 1 upon 1 minus r, common ratio is c by z. Now simplifying this term we get cz upon 1 minus cz, plus here z is LCM, goes in the numerator, then we have z upon z minus c. Taking LCM and simplify, we get z minus c square z upon 1 minus cz into z minus c, which is the z transform of the given sequence. Now for reason of convergence, we have this common ratio cz should be less than 1, common ratio cz should be less than 1, which gives z is greater than 1 upon c, and here the common ratio c by z should less than 1, then we have mod z is greater than c. So the region of convergence is lying between 1 upon c to c. So this is how we find the z transform and the region of convergence. In next video we will discuss few more important examples on z transform. So see you in next video. Thank you. For region of convergence, once again, for the first series common ratio is cz, so mod cz less than 1, this implies mod z is less than 1 upon c, and for the second series, the common ratio is C by Z. So for the convergence, mod C by Z is less than 1, which implies mod Z is greater than C. So the region of convergence is C is less than mod Z, and which is less than 1 upon C. So region of convergence is C is less than Z, and which is less than 1 upon C.